Mars has captured humanity's imagination for centuries, appearing as a rusty red beacon in our night sky that seems to whisper promises of adventure and new beginnings. Billionaires are spending fortunes to get us there, space agencies are planning missions, and Hollywood keeps painting pictures of thriving Martian colonies. But today, we're diving deep into the scientific evidence that reveals why the red planet isn't just inhospitable. It's a death trap that would challenge every system in your body from the moment you step foot on its surface. And here's something I'm genuinely curious about. If you had to choose between living on Mars for 1 year or spending that same year in Antarctica during winter, which one would you pick? And let me know why in the comments down below. I will pin the most creative answer. Now let's begin. The first thing that would assault your body on Mars is the atmosphere, or rather the lack of one. Earth's atmosphere is a protective blanket that we take completely for granted, but on Mars you're dealing with an atmospheric pressure that's less than 1% of what we experience at sea level. To put this in perspective, the atmospheric pressure on Mars is equivalent to being 35 kilometers above Earth's surface, higher than commercial jets fly and well into the stratosphere. This impossibly thin atmosphere creates a cascade of life-threatening problems that begin the instant you're exposed to it. Without a pressure suit, your saliva would literally boil on your tongue. The water in your bloodstream would start forming bubbles, causing a condition called ebulism that would make you feel like you're being carbonated from the inside out. Your lungs would be useless. There simply isn't enough air pressure to force oxygen into your bloodstream, even if you could somehow breathe the carbon dioxide that makes up 96% of the Martian atmosphere. But the atmospheric nightmare doesn't stop there. The lack of atmospheric pressure means that liquid water cannot exist on most of the Martian surface. Any water would instantly boil away into vapor, regardless of temperature. This isn't just inconvenient, it's biologically catastrophic. Your body is roughly 60% water, and every cellular process depends on liquid water remaining liquid. The low-pressure environment would constantly work against your body's ability to maintain proper hydration and cellular function. The temperature variations on Mars would subject your body to thermal stress that makes Earth's most extreme environments look comfortable. While summer temperatures at the Martian equator can occasionally reach a pleasant 20 degrees Celsius, the average global temperature hovers around -63 degrees Celsius. During winter at the poles, temperatures plummet to -125 degrees Celsius, cold enough to freeze carbon dioxide out of the atmosphere. These aren't just uncomfortable temperature swings, they represent thermal conditions that would rapidly overwhelm your body's ability to regulate its core temperature. Hypothermia would set in within minutes of exposure, and the extreme cold would cause frostbite so severe that your extremities would literally freeze solid. Even with the best insulation technology we have, maintaining body heat in such an environment would require enormous amounts of energy and sophisticated heating systems that could fail catastrophically. The daily temperature variations are equally brutal. On a typical Martian day, temperatures can swing by 100 degrees Celsius or more. Your habitat and equipment would expand and contract constantly, creating stress fractures and seal failures that could prove fatal. The thermal cycling would be like living inside a machine that's constantly trying to tear itself apart. The radiation environment on Mars represents perhaps the most insidious threat to human survival. Unlike Earth, Mars has no global magnetic field to deflect the deadly charged particles streaming from the Sun and deep space. The planet's thin atmosphere provides virtually no protection against cosmic radiation, gamma rays, and solar particle events that would slowly but surely destroy your DNA and cellular structures. NASA's Curiosity rover has been measuring radiation levels on Mars since 2012, and the data is sobering. An astronaut on the Martian surface would receive roughly 100 times more radiation than someone living on Earth. Over the course of a typical Mars mission lasting 2 to 3 years, including travel time, an astronaut would accumulate a radiation dose equivalent to getting a full-body CT scan every few days. This chronic radiation exposure would dramatically increase your risk of cancer, cataracts, and acute radiation syndrome. But the effects go deeper than that. Cosmic radiation can cause cognitive impairment, affecting memory, decision-making, and motor skills. Studies on astronauts who have spent extended time in space show measurable decreases in brain function that could prove catastrophic during critical mission operations. If you're finding these Martian survival challenges as fascinating and terrifying as I am, I'd really appreciate it if you could hit that subscribe button and give this video a thumbs up. We're just getting started on this journey through the deadly realities of Mars, and your support helps me continue bringing these incredible scientific discoveries to light. Solar particle events represent an even more immediate radiation threat. When the Sun releases massive bursts of charged particles during solar flares and coronal mass ejections, Mars receives the full brunt of this radiation with no atmospheric or magnetic protection. During a major solar particle event, radiation levels on Mars can spike to lethal doses within hours. An unprotected human on the surface during such an event would receive a fatal dose of radiation in a matter of minutes. The dust on Mars isn't just an inconvenience, it's a toxic, electrostatically charged menace that would infiltrate every aspect of your existence. Martian dust particles are incredibly fine, much smaller than typical Earth dust, and they carry electrostatic charges that make them cling to everything they touch. This dust would coat your equipment, clog your air filters, and find its way into your habitat despite your best efforts to keep it out. But the real danger lies in the chemical composition of Martian dust. The soil contains high concentrations of perchlorates, toxic chemicals that are used in rocket fuel and explosives here on Earth. These compounds are poisonous to humans, causing thyroid problems, developmental issues, and potentially fatal metabolic disruptions. Every time you track dust into your habitat or handle contaminated equipment, you'd be exposing yourself to these dangerous chemicals. The electrostatic properties of Martian dust create additional hazards that could prove fatal. The dust builds up massive electrical charges that could damage sensitive electronic equipment, disrupt communications, and even pose fire and explosion risks. During dust storms, the electrical activity can be so intense that it interferes with radio communications and satellite operations. Martian dust storms can engulf the entire planet for months at a time, as happened in 2018 when a global dust storm effectively ended the Opportunity rover's mission after nearly 15 years of operation. During such storms, solar panels become useless, temperatures drop dramatically, and visibility approaches zero. A human crew caught in a global dust storm would face a survival scenario that makes Antarctic blizzards look like gentle spring showers. The psychological challenges of living on Mars would be just as deadly as the physical ones. You'd be trapped in a small, confined space with the same people for years, knowing that Earth is millions of kilometers away and that rescue is impossible. The isolation would be absolute, more complete than any human has ever experienced. Even radio communications with Earth would have delays of up to 24 minutes each way, making real-time conversation impossible. The sensory deprivation would be profound. Mars has no blue skies, no clouds, no weather patterns that resemble anything familiar from Earth. The landscape is a monotonous expanse of rust-colored rocks and dust stretching to the horizon in every direction. There are no sounds except what you make yourself. No wind through trees, no bird songs, no ocean waves. The silence would be oppressive and psychologically devastating. Studies of people in extreme isolation, such as Antarctic research stations and submarine crews, show that even the most psychologically stable individuals can develop severe mental health problems, including depression, anxiety, paranoia, and cognitive decline. On Mars, these problems would be amplified by the knowledge that you're completely cut off from everything familiar and that any mistake could be fatal. The sleep disruption alone would slowly drive you insane. Mars has a day length of 24 hours and 37 minutes, which might seem close to Earth's 24-hour cycle, but this small difference would wreak havoc on your circadian rhythms. Your body's internal clock, evolved over millions of years to sync with Earth's rotation, would constantly struggle to adapt to the slightly longer Martian day. Research on shift workers and people with circadian rhythm disorders shows that even small disruptions to sleep cycles can cause serious health problems, including cardiovascular disease, diabetes, immune system dysfunction, and severe mental health issues. On Mars, you'd be living in a state of permanent jet lag that would compound all the other stresses on your body and mind. The lack of natural sunlight would make the psychological challenges even worse. Mars receives only 43% of the sunlight that Earth gets, and the Sun appears as a pale, distant disk in the butterscotch-colored Martian sky. This reduced light exposure would disrupt your body's production of vitamin D and serotonin, leading to seasonal affective disorder, depression, and bone density loss. The social dynamics of a Mars mission would create a pressure cooker environment where personality conflicts could escalate into life-threatening situations. You'd be completely dependent on your crewmates for survival, yet trapped with them in a confined space with no possibility of escape or outside intervention. Historical examples from polar expeditions and isolated research stations show how quickly cooperation can break down under extreme stress. The medical challenges on Mars would be absolutely catastrophic. There would be no hospitals, no emergency rooms, no specialists, and no possibility of medical evacuation. Every medical emergency would have to be handled with whatever supplies and expertise you brought with you. A simple appendicitis, which is easily treatable on Earth, could become a death sentence on Mars. Surgery in the low-gravity, low-pressure environment of Mars would present unprecedented challenges. Blood and other bodily fluids would behave differently in the reduced gravity, making surgical procedures extremely difficult. Anesthesia would be complicated by the atmospheric conditions, and post-operative recovery would be hampered by the radiation environment and psychological stress. The human immune system, already compromised by radiation exposure and psychological stress, would struggle to fight off infections in the Martian environment. Minor cuts and scrapes could become serious infections without proper medical care. The closed-loop life support systems would create ideal conditions for the spread of infectious diseases among the crew. Bone density loss would be a constant, progressive threat to your health. The reduced gravity on Mars, about 38% of Earth's gravity, would cause your bones to lose calcium and become brittle over time. This isn't just a long-term concern, it would affect your ability to perform physical tasks and increase your risk of fractures from even minor accidents. Muscle atrophy would be equally problematic. Without the constant resistance provided by Earth's gravity, your muscles would begin to waste away despite exercise regimens. Your cardiovascular system would also deteriorate, making it increasingly difficult to perform the physical work necessary for survival on Mars. The water situation on Mars would be a constant life or death struggle. While we know that water ice exists on Mars, extracting, purifying, and maintaining a reliable water supply would be enormously challenging. The water extraction process would require significant energy, and any failure in the water recycling systems could be fatal within days. Martian water sources are likely contaminated with perchlorates and other toxic compounds that would need to be removed through complex filtration and purification processes. The equipment required for this would be heavy, energy-intensive, and prone to failure. A single malfunction in your water processing system could leave you without safe drinking water in one of the most hostile environments imaginable. The energy requirements for survival on Mars would be staggering. You'd need power for life support systems, heating, water processing, food production, communications, and countless other essential functions. Solar panels would be your primary power source, but they'd be constantly degraded by dust accumulation and radiation damage. During dust storms, solar power generation could drop to near zero for months at a time. Nuclear power systems would be more reliable, but would add their own risks and complications. Maintaining nuclear reactors on Mars would require specialized expertise and spare parts that might not be available. Any failure in your power systems would quickly cascade into a complete life support failure. Speaking of the comprehensive challenges of Mars exploration, if you want to dive even deeper into the fascinating science behind the red planet, from its formation billions of years ago to the cutting-edge missions exploring it today, you should check out my video, the most complete video about Mars on YouTube. It covers everything from Martian geology and climate history to the latest discoveries from rovers and orbiters, giving you the full picture of this incredible world that's simultaneously beautiful and deadly. The link is in the description and on the card above. Food production on Mars would be a nightmare of complexity and failure points. You couldn't simply pack enough food for a multi-year mission. The weight and storage requirements would be prohibitive. Instead, you'd need to grow food in artificial environments using Martian soil that's toxic to most Earth plants. The Martian soil contains not only perchlorates but also heavy metals and lacks the beneficial microorganisms that Earth plants depend on. Creating artificial growing medium would require extensive processing and the addition of nutrients and beneficial bacteria brought from Earth. The energy requirements for maintaining proper growing conditions, temperature, humidity, lighting, would be enormous. Crop failures would be catastrophic. Unlike on Earth, where failed harvests can be supplemented by food from other regions, a crop failure on Mars could mean starvation. The psychological pressure of knowing that your survival depends on successfully growing food in an alien environment would be overwhelming. The atmospheric composition of Mars would create constant challenges for your life support systems. The atmosphere is 96% carbon dioxide, with virtually no oxygen. Your life support systems would need to constantly scrub CO2 from your habitat's atmosphere while generating oxygen through electrolysis or other processes. These systems would be incredibly complex and energy-intensive, with multiple failure points that could prove fatal. The backup systems for your backup systems would need backup systems. Every component would need to be redundant because failure isn't just inconvenient on Mars, it's deadly. The lack of atmospheric pressure would also affect how your equipment functions. Seals and gaskets would behave differently, lubricants would evaporate more quickly, and electronic components would be more susceptible to failure. Every piece of equipment would need to be specially designed and tested for the Martian environment. Communication delays with Earth would create dangerous situations where you couldn't get real-time help when you need it most. Depending on the orbital positions of Earth and Mars, radio signals can take anywhere from 4 to 24 minutes to travel between the planets. This means that any emergency requiring immediate expert consultation would have to be handled entirely by the crew on Mars. Imagine trying to perform emergency surgery with a 48-minute delay between asking a question and receiving an answer from medical experts on Earth. Or troubleshooting a critical life support system failure when the engineers who designed it are 24 minutes away by radio. The isolation would be absolute and terrifying. The equipment maintenance requirements on Mars would be relentless and unforgiving. Every system would be operating at the edge of its design limits in an environment it was never meant to handle. Dust infiltration, radiation damage, thermal cycling, and the corrosive effects of perchlorates would cause constant equipment failures. You'd need to be an expert mechanic, electrician, computer technician, and engineer, all rolled into one. The spare parts inventory would need to be enormous. but weight and space limitations would force difficult choices about what to bring and what to leave behind. When critical components fail, and they will fail, you'd need to improvise repairs using whatever materials you have available. The manufacturing capabilities on Mars would be virtually non-existent, meaning that when something breaks, you'd have extremely limited options for replacement or repair. Unlike the International Space Station, which can receive regular resupply missions from Earth, a Mars crew would be completely on their own for years at a time. Every tool, every spare part, every component would need to be brought from Earth or somehow fabricated using the limited resources available on Mars. Three-dimensional printing technology might help with some basic components, but the raw materials for printing would still need to come from Earth or be extracted from Martian resources using complex industrial processes. The idea of mining and refining metals on Mars sounds exciting in theory, but the reality would involve massive, energy-intensive operations that would be far beyond the capabilities of a small crew struggling just to survive. The psychological impact of equipment failures would be devastating. Every malfunction would be a reminder of how precarious your situation is and how dependent you are on technology that's slowly degrading in an environment that's actively hostile to its operation. The constant stress of knowing that any failure could be fatal would take an enormous psychological toll. The waste management challenges on Mars would be both disgusting and potentially deadly. Every bit of waste, human waste, food scraps, broken equipment, contaminated materials, would need to be carefully processed and recycled. Nothing could simply be thrown away because there is no away on Mars. Human waste would need to be processed to recover water and nutrients while eliminating pathogens and toxic compounds. The systems required for this would be complex, energy-intensive, and prone to failure. A malfunction in your waste processing systems could quickly lead to contamination of your water supply or the buildup of toxic gases in your habitat. The closed-loop nature of your life support systems would mean that any contamination or system failure would affect everything else. A problem with waste processing could contaminate your water supply. A failure in your air recycling system could lead to carbon dioxide poisoning. Everything would be interconnected, creating cascading failure scenarios that would be nearly impossible to prevent. The fire safety challenges on Mars would be uniquely terrifying. Fire behaves very differently in low-pressure, low-oxygen environments, making it both harder to start and harder to extinguish once it begins. Your habitat would need to maintain higher oxygen concentrations than the Martian atmosphere, creating fire risks that would be difficult to manage. In the event of a fire, you couldn't simply evacuate to the outside environment like you could on Earth. The Martian atmosphere would kill you faster than the fire would. You'd be trapped inside your habitat with a fire that might be impossible to extinguish using conventional methods. The toxic smoke and fumes would have nowhere to go, potentially making your entire living space uninhabitable. Fire suppression systems designed for Earth wouldn't work properly in the Martian environment. Water-based systems would be problematic because water behaves differently at low pressure. Chemical suppression systems would need to be specially designed for the unique atmospheric conditions on Mars. The structural integrity of your habitat would be constantly threatened by the extreme environmental conditions. The daily temperature swings would cause materials to expand and contract repeatedly, creating stress fractures and seal failures. The low atmospheric pressure would put constant outward pressure on your habitat's walls, like living inside a balloon that's always trying to burst. Micrometeorite impacts would be a constant threat. Earth's atmosphere burns up most small space debris before it reaches the surface, but Mars's thin atmosphere provides little protection. Your habitat would be constantly bombarded by tiny particles traveling at tremendous speeds, gradually wearing away protective coatings and potentially causing catastrophic breaches. The building materials available on Mars would be extremely limited. You couldn't simply order concrete or steel beams when you need to expand or repair your habitat. Any construction would need to use materials that could be processed from the Martian environment or brought from Earth at enormous cost and weight penalties. The dust infiltration problem would be far worse than most people realize. Martian dust is incredibly fine, much finer than typical Earth dust, and it carries electrostatic charges that make it cling to everything. This dust would find its way into every seal, every bearing, every electronic component, gradually degrading everything it touches. The dust isn't just an annoyance, it's actively toxic. The high concentrations of perchlorates in Martian dust would make it dangerous to handle without protective equipment. Every time you go outside and come back in, you'd be bringing this toxic dust with you, gradually contaminating your living environment. Cleaning systems would be essential but energy-intensive. You'd need airlocks with sophisticated decontamination procedures, but even the best systems wouldn't be 100% effective. Over time, the dust contamination would build up, creating health hazards and equipment failures. The lack of a substantial magnetosphere on Mars means that the planet is constantly being bombarded by charged particles from the solar wind. This doesn't just create radiation hazards for humans, it also affects electronic equipment in ways that are difficult to predict and prevent. Electronic components would be subject to single-event upsets, where cosmic rays cause temporary or permanent malfunctions in computer systems. These events are rare on Earth because our magnetosphere deflects most cosmic radiation, but they would be common on Mars. Critical systems could fail without warning due to radiation-induced errors. The cumulative effects of radiation damage would gradually degrade all electronic equipment. Solar panels would lose efficiency over time, computer processors would develop errors, and communication systems would become unreliable. The redundancy required to maintain reliable operations would be enormous. The seasonal changes on Mars would create additional survival challenges that go far beyond simple temperature variations. During winter, carbon dioxide from the atmosphere freezes out at the polar caps, reducing the already thin atmospheric pressure even further. This seasonal pressure change would affect everything from your life support systems to the behavior of any liquids in your habitat. Dust storm seasons would bring months-long periods of reduced solar power generation and increased equipment wear. The electrostatic activity during these storms would create additional hazards for electronic equipment and could interfere with communications with Earth at critical moments. The seasonal changes in atmospheric composition would also affect your ability to extract resources from the Martian environment. Water extraction processes that work during summer might fail during winter, when temperatures drop below the operating limits of your equipment. The gravity difference between Mars and Earth would create long-term health problems that go beyond simple bone and muscle loss. Your cardiovascular system, evolved to work against Earth's gravity, would gradually adapt to the lower gravity environment. This adaptation would make it increasingly difficult to return to Earth, potentially making Mars colonists permanent exiles. The reduced gravity would also affect how fluids behave in your body. Blood circulation, lymphatic drainage, and even digestion would all be affected by the different gravitational environment. These changes could lead to health problems that we don't fully understand because no human has ever lived in reduced gravity for extended periods. Balance and spatial orientation would be constantly challenging. Your inner ear, which helps maintain balance, is calibrated for Earth's gravity. In the reduced gravity of Mars, you'd be prone to motion sickness, disorientation, and falls that could be dangerous in an environment where medical help is limited. The psychological effects of living under an alien sky would be more profound than most people realize. The sun would appear smaller and dimmer, the sky would be a butterscotch color instead of blue, and there would be no familiar celestial landmarks. The two small moons of Mars would provide little comfort compared to Earth's large, bright moon. The lack of familiar seasonal cues would disrupt your psychological well-being in ways that are difficult to predict. There would be no spring flowers, no autumn leaves, no familiar weather patterns that mark the passage of time. The psychological comfort that comes from seasonal changes and natural beauty would be completely absent. The knowledge that you're living on a dead world would be psychologically devastating. Mars has no biosphere, no ecosystem, no signs of life beyond what you bring with you. The landscape would be sterile and unchanging, a constant reminder that you're living in a place where life doesn't belong. The reproductive challenges on Mars would represent perhaps the most fundamental threat to any long-term human presence. The combination of radiation exposure, reduced gravity, psychological stress, and nutritional limitations would create conditions that are likely incompatible with healthy human reproduction. Studies on animals exposed to space radiation show increased rates of birth defects, developmental problems, and reproductive failures. The developing fetus would be particularly vulnerable to the high radiation environment on Mars. Cosmic radiation and solar particle events could cause genetic damage that leads to miscarriages, birth defects, or childhood cancers. The reduced gravity environment might also affect fetal development in ways we don't fully understand, potentially leading to children who are physically unable to survive in Earth's gravity. Even if pregnancy was somehow successful, raising children on Mars would present impossible challenges. Children would need specialized equipment, different nutritional requirements, and constant medical monitoring that would strain already limited resources. A sick child on Mars could quickly become a life-or-death emergency with no possibility of specialized pediatric care. The educational and psychological development of children raised on Mars would be severely compromised. They would grow up in a sterile, confined environment with no access to nature, limited social interaction, and the constant stress of knowing that their survival depends on technology that could fail at any moment. The psychological damage from such an upbringing could be irreversible. The water recycling systems on Mars would need to achieve levels of efficiency that are barely possible with current technology. Every drop of water would need to be captured, processed, and reused indefinitely. The closed-loop water systems would need to handle not just drinking water and hygiene needs, but also water for food production, equipment cooling, and emergency reserves. The complexity of these water systems would be staggering. You'd need multiple redundant filtration systems, chemical treatment processes, biological treatment components, and monitoring systems to ensure water quality. Any failure in these systems could contaminate your entire water supply, potentially making it undrinkable or even toxic. The psychological pressure of knowing that your water supply is completely dependent on mechanical systems would be enormous. Unlike on Earth, where you can find alternative water sources if your primary supply fails, on Mars there would be no backup plan. Equipment failure would mean death by dehydration within days. The atmospheric processing requirements would push technology to its absolute limits. Your life support systems would need to maintain precise atmospheric composition, pressure, and humidity levels while constantly scrubbing carbon dioxide and generating oxygen. The energy requirements for these processes would be enormous, and any failure could be fatal within hours. The backup systems for atmospheric processing would need to be incredibly robust because there's no margin for error. You couldn't simply open a window for fresh air if your systems failed. The Martian atmosphere would kill you in minutes, making atmospheric system failures immediately life-threatening. The complexity of maintaining proper atmospheric conditions would require constant monitoring and adjustment. Temperature, humidity, oxygen levels, carbon dioxide concentrations, and trace gas levels would all need to be carefully controlled. The psychological stress of knowing that your next breath depends on machines working perfectly would be overwhelming. The food storage and preservation challenges on Mars would be unlike anything faced on Earth. Without the option of regular resupply missions, you'd need to store food for years at a time while maintaining nutritional value and preventing spoilage. The radiation environment would gradually degrade stored food, breaking down vitamins and creating toxic compounds. The limited variety of available foods would lead to nutritional deficiencies that could compromise your health and immune system. Fresh fruits and vegetables would be impossible to obtain except for what you could grow yourself, and the psychological effects of eating the same processed foods day after day for years would be devastating. Food safety would be a constant concern with no margin for error. Food poisoning that might be a minor inconvenience on Earth could be fatal on Mars, where medical resources are extremely limited. Every meal would need to be carefully prepared and monitored to prevent contamination. The equipment redundancy requirements would make any Mars mission incredibly complex and expensive. Every critical system would need multiple backups, and every backup would need its own backup. The weight and space requirements for all this redundant equipment would be enormous, making missions extremely difficult to plan and execute. Despite all this redundancy, single points of failure would still exist. Some systems are so complex or massive that complete redundancy isn't practical. The failure of these critical systems could doom an entire mission, making Mars exploration an incredibly high-risk endeavor. The maintenance requirements for all this redundant equipment would be overwhelming. A small crew would need to be experts in dozens of different systems, capable of diagnosing and repairing everything from life support systems to communication equipment to power generation systems. The communication blackouts with Earth would create periods of complete isolation that could last for weeks. When Mars passes behind the Sun, from Earth's perspective, radio communications become impossible due to solar interference. During these blackout periods, the Mars crew would be completely cut off from Earth, with no possibility of receiving help or guidance. These blackout periods would occur predictably every 26 months and could last for up to 2 weeks. Any emergency that occurred during a blackout would need to be handled entirely by the crew on Mars. The psychological pressure of knowing that help is completely unavailable would be enormous. The timing of these blackouts could be catastrophic if they coincided with equipment failures or medical emergencies. Critical decisions that might benefit from Earth-based expertise would need to be made without any outside consultation. The launch window constraints for Mars missions would create additional psychological pressure. Unlike missions to the Moon or low Earth orbit, Mars missions can only be launched during specific windows that occur every 26 months when the planets are properly aligned. Missing a launch window means waiting over 2 years for the next opportunity. This constraint means that Mars crews would be committed to staying on the planet for at least 2 years, regardless of what happens during their mission. There would be no possibility of early return if things go wrong. The psychological pressure of knowing that you're trapped on Mars until the next launch window would be overwhelming. The return journey to Earth would present its own set of deadly challenges. After spending years in the reduced gravity and radiation environment of Mars, your body would be severely weakened and potentially unable to survive the stresses of launch and the journey back to Earth. The spacecraft needed for the return journey would need to be maintained on Mars for years, while exposed to dust storms, radiation, and extreme temperature variations. The reliability of equipment that has been sitting on Mars for years would be questionable at best. The re-entry into Earth's gravity after years on Mars could be physically devastating. Your bones would be brittle, your muscles atrophied, and your cardiovascular system weakened. The transition back to Earth's gravity could cause fractures, heart problems, and other medical emergencies. The contamination protocols for returning from Mars would be incredibly strict. Any samples or equipment brought back from Mars would need to be quarantined to prevent the possibility of introducing Martian microorganisms to Earth's biosphere. The crew themselves might need to be quarantined for extended periods. The long-term health effects of Mars exposure would be largely unknown. The combination of radiation exposure, reduced gravity, psychological stress, and exposure to toxic Martian dust could cause health problems that don't manifest until years after returning to Earth. Mars astronauts could face increased cancer risks, neurological problems, and other health issues for the rest of their lives. The cost of Mars missions would be so enormous that they would likely be one-way trips for economic reasons. The expense of maintaining life support systems, bringing enough supplies, and providing redundant equipment for a return mission would be prohibitive. This economic reality would add another layer of psychological pressure to an already impossible situation. The knowledge preservation problem becomes even more critical when you consider that Mars colonists would need to maintain expertise in thousands of different technical fields simultaneously. On Earth, we can afford specialization because we have billions of people and robust communication networks. On Mars, a small colony would need to preserve knowledge about everything from nuclear engineering to agriculture, from medicine to electronics, all while struggling just to survive. The loss of a single expert could be catastrophic for a Mars colony. If your only person with medical training dies, the entire colony loses access to medical care. If your electronics expert has an accident, critical systems might become unrepairable. The redundancy in human expertise that we take for granted on Earth would be impossible to maintain on Mars. The educational burden on Mars colonists would be overwhelming. Everyone would need to be cross-trained in multiple critical skills, but human learning capacity has limits. You can't expect someone to be simultaneously expert in medicine, engineering, agriculture, and electronics. The knowledge gaps would be inevitable and potentially fatal. The library and information storage systems on Mars would need to contain the entire accumulated knowledge of human civilization, but in a format that can survive equipment failures, power outages, and environmental hazards. Digital storage is vulnerable to radiation damage and equipment failure. Physical books are heavy and vulnerable to fire and environmental damage. The manufacturing capabilities needed to maintain a technological civilization on Mars would require an industrial base that takes decades to establish. You can't manufacture computer processors without semiconductor fabrication facilities. You can't make advanced materials without chemical processing plants. You can't maintain these facilities without a massive supply chain of raw materials and components. The bootstrap problem for Mars industrialization is nearly insurmountable. To build the factories needed to make advanced technology, you need advanced technology. To get the advanced technology, you need the factories. Breaking this circular dependency would require bringing enormous amounts of industrial equipment from Earth, making the initial investment astronomical. The energy infrastructure on Mars would need to be incredibly robust and redundant. Solar panels would be your primary power source, but they'd be constantly degraded by dust accumulation and radiation damage. The cleaning and maintenance requirements would be enormous, and replacement panels would need to be manufactured locally or brought from Earth at great expense. Nuclear power would be more reliable, but would require nuclear fuel, specialized expertise, and complex safety systems. The waste heat from nuclear reactors could be useful for heating habitats, but the radiation shielding requirements would be enormous. Any accident with a nuclear reactor on Mars could contaminate the entire colony. The backup power systems would need to be capable of maintaining life support during extended power outages. Battery technology capable of storing enough energy for days or weeks of life support would be massive and expensive. Fuel cells would require hydrogen and oxygen, which would need to be manufactured locally using precious water resources. The transportation infrastructure on Mars would be essential for colony expansion, but incredibly difficult to establish. Roads would need to be built across terrain that includes massive dust storms, extreme temperature variations, and radiation exposure. Vehicles would need to be designed for conditions that don't exist on Earth. The maintenance requirements for Mars vehicles would be enormous. The dust, radiation, and temperature extremes would cause constant equipment failures. Replacement parts would need to be manufactured locally or brought from Earth. The expertise needed to maintain complex vehicles would add to the already overwhelming skill requirements for colonists. The communication infrastructure on Mars would need to maintain contact not just with Earth, but between different parts of the colony as it expands. Radio communications would be affected by dust storms and solar interference. The relay stations needed for colony-wide communications would need to be maintained across vast distances in hostile terrain. The expansion challenges for Mars colonies would multiply the survival difficulties exponentially. Each new habitat would need its own life support systems, power generation, and emergency backup systems. The complexity of maintaining multiple interconnected facilities would quickly become overwhelming for a small population. The site selection for colony expansion would be critical, but difficult. You'd need locations with access to water, protection from radiation, stable ground for construction, and proximity to resources. The geological surveys needed to identify suitable sites would require expertise and equipment that might not be available. The construction capabilities on Mars would be severely limited by the lack of traditional building materials. Concrete requires water, which is precious on Mars. Steel requires iron ore and complex smelting operations. Most construction would need to rely on materials that can be processed from the Martian environment using simple techniques. The habitat design challenges would be unlike anything faced on Earth. Structures would need to maintain pressure differentials, provide radiation shielding, withstand extreme temperature variations, and resist dust infiltration. The engineering requirements would push the limits of current technology. The life support scaling problems would become worse as colonies grow larger. Larger populations would need more complex waste processing, water recycling, and atmospheric management systems. The failure modes for these systems would become more complex and harder to predict as they scale up. The social organization challenges would multiply as Mars colonies grow beyond small groups. How do you govern a community when everyone's survival depends on cooperation, but resources are limited? Democratic processes that work on Earth might be inadequate for the life or death decisions that Mars colonists would face daily. The economic systems on Mars would need to be completely different from Earth economies. Traditional concepts of money, property, and trade would be meaningless when everyone's survival depends on shared resources and cooperation. The economic incentives that drive innovation and productivity on Earth might not work on Mars. The trade relationships between Mars and Earth would be severely constrained by the enormous costs and time delays involved in interplanetary transportation. Mars colonies would need to be essentially self-sufficient because relying on Earth for critical supplies would be economically and logistically impossible. The research and development capabilities on Mars would be limited by the small population and survival priorities. Scientific research requires resources, equipment, and expertise that might not be available when everyone is focused on basic survival. The advancement of human knowledge could stagnate in Mars colonies. The cultural development on Mars would be constrained by the harsh survival requirements. Art, music, literature, and other cultural expressions require leisure time and resources that might not be available. The psychological impact of a culture focused entirely on survival would be devastating. The religious and philosophical challenges on Mars would be profound. How do traditional Earth religions adapt to life on another planet? What new belief systems might emerge from the unique challenges of Mars colonization? The spiritual needs of colonists would be difficult to address in a survival-focused environment. The generational planning requirements for Mars colonies would extend far beyond typical human planning horizons. Decisions made by the first generation of colonists would affect their descendants for centuries. The responsibility of making decisions that will determine the fate of future generations would be overwhelming. The genetic management requirements for long-term Mars colonies would involve difficult ethical decisions about reproduction, genetic screening, and population control. The small founding population would require careful genetic management to prevent inbreeding and maintain genetic diversity. The terraforming possibilities that are often discussed as solutions to Mars habitability problems would take thousands of years and require technology that doesn't exist. Even if terraforming were possible, it wouldn't help the first several hundred generations of Mars colonists who would need to survive in the current hostile environment. The planetary protection requirements would create additional constraints on Mars colonies. Contamination of Mars with Earth organisms could interfere with scientific research and potentially damage any existing Martian ecosystems. The sterilization requirements for equipment and habitats would add complexity and cost to every aspect of colonization. The backup planet concept that motivates much Mars colonization discussion ignores the reality that Mars colonies would be completely dependent on Earth for decades or centuries. A catastrophe that destroys Earth civilization would also doom Mars colonies that depend on Earth for critical supplies and expertise. The backup planet mythology surrounding Mars colonization fundamentally misunderstands the relationship between Earth and any potential Mars colony. For centuries, Mars would be more like an Antarctic research station than an independent civilization, completely dependent on the home planet for survival. If Earth suffered a catastrophic event that ended technological civilization, Mars colonies would follow within months as their life support systems failed and replacement parts ran out. The technological regression risk on Mars would be enormous. Unlike Earth civilizations that can fall back on simpler technologies when complex systems fail, Mars colonists would have no fallback options. If advanced technology fails on Mars, there's no hunting and gathering, no subsistence farming, no primitive shelter options. Technological failure on Mars means death, making the colony incredibly fragile. The single point of failure problem extends beyond individual systems to the entire concept of Mars colonization. Earth is the single point of failure for Mars colonies. Any disruption to Earth's ability to support Mars missions, whether from war, economic collapse, natural disasters, or political changes, would doom Mars colonies that depend on Earth for survival. The political stability requirements for successful Mars colonization are rarely discussed but absolutely critical. Mars missions require decades of sustained political and economic commitment from Earth governments. Changes in political leadership, economic priorities, or public opinion could end support for Mars colonies, leaving colonists stranded without supplies or rescue options. The international cooperation requirements for Mars colonization would be unprecedented. No single nation has the resources to establish and maintain Mars colonies independently. The international agreements needed to coordinate Mars colonization would be incredibly complex and vulnerable to political disputes that could leave colonists caught in the middle of Earth-based conflicts. The military implications of Mars colonization would create new forms of international tension. Who controls Mars colonies? What happens if Earth nations disagree about Mars policies? Could Mars colonies become military targets in Earth-based conflicts? The weaponization of space that Mars colonization might trigger could make Earth less safe, not more. The environmental ethics of Mars colonization raise profound questions about humanity's right to colonize other planets. Mars might have its own ecosystem of microorganisms that we haven't discovered yet. Colonization could destroy these ecosystems before we even know they exist, representing an irreversible loss of scientific knowledge and potentially unique forms of life. The resource extraction requirements for Mars colonies would have devastating environmental impacts on the planet. Mining operations needed to extract metals, water, and other resources would permanently alter the Martian landscape. The industrial pollution from manufacturing and energy production would contaminate the Martian environment. The waste accumulation problems on Mars would be far worse than on Earth because there are no natural recycling processes. Every piece of trash, every broken component, every contaminated material would accumulate permanently. Over time, Mars colonies could become surrounded by growing piles of waste that pose health and safety hazards. The atmospheric modification attempts that some propose for Mars terraforming could have unintended consequences that make the planet even less habitable. Releasing greenhouse gases to thicken the atmosphere might trigger runaway climate change that makes Mars uninhabitable. The complexity of planetary atmospheres makes terraforming incredibly risky. The timeline realities for Mars colonization are far longer than most people realize. Establishing a self-sufficient Mars colony would take centuries, not decades. The first several generations of Mars colonists would be essentially experimental subjects, testing whether long-term human survival on Mars is even possible. The mortality rates for early Mars colonists would be extremely high. The combination of radiation exposure, equipment failures, medical emergencies, and psychological stress would create death rates far higher than anything experienced by Earth populations. The ethical implications of sending people on missions with such high mortality rates are profound. The selection criteria for Mars colonists would involve impossible choices about who deserves the chance to survive if Earth faces catastrophe. The selection process would inevitably favor young, healthy, educated people from wealthy nations, raising questions about equity and justice in humanity's expansion to other planets. The psychological screening for Mars colonists would need to identify people capable of accepting permanent exile, extreme isolation, constant danger, and the knowledge that their mission might fail. The psychological profile needed for Mars colonization might be incompatible with the mental health needed for long-term survival and reproduction. The training requirements for Mars colonists would be so extensive that it would consume most of their adult lives. Learning all the skills needed for Mars survival would require decades of education and training. The opportunity cost of this training would be enormous, preventing colonists from contributing to Earth society during their most productive years. The family separation issues for Mars colonists would be devastating. Colonists would need to permanently leave behind parents, siblings, friends, and extended family with no possibility of reunion. The psychological impact of this permanent separation would be enormous, particularly for colonists who have children on Mars who will never meet their Earth-based grandparents. The cultural preservation challenges would extend beyond maintaining Earth traditions to creating new cultural forms adapted to Mars conditions. The art, music, literature, and social customs that develop on Mars would be shaped by survival requirements and might be incomprehensible to Earth-based humans. The language evolution on Mars would gradually separate Mars colonists from Earth communication. Technical terminology specific to Mars survival would develop, while Earth-based cultural references would become meaningless. Over time, Mars colonists might develop distinct dialects or even separate languages. The legal jurisdiction questions for Mars colonies have no clear answers. What laws apply on Mars? Which Earth courts have jurisdiction over crimes committed on Mars? How are contracts enforced across interplanetary distances? The legal framework for Mars colonization would need to be developed from scratch. The property rights issues on Mars would create new forms of international conflict. Who owns Mars land? Can Earth nations claim territory on Mars? What happens when different groups claim the same resources? The potential for conflict over Mars resources could destabilize international relations on Earth. The insurance and liability issues for Mars missions would be unprecedented. No insurance company could cover the risks involved in Mars colonization. The liability for mission failures, colonist deaths, or environmental damage would be impossible to calculate or assign. The legal and financial risks would be enormous. The return journey impossibility for most Mars colonists would make Mars missions effectively one-way trips. The physical deterioration from years in reduced gravity and high radiation would make many colonists unable to survive the return journey to Earth. Mars colonization would be permanent exile for most participants. The adaptation requirements for Mars-born humans would make them increasingly incompatible with Earth environments. Children born and raised in Mars gravity might be unable to survive in Earth's stronger gravitational field. Their bone density, muscle mass, and cardiovascular systems would be adapted to Mars conditions. The speciation potential for Mars humans raises the possibility that Mars colonists could evolve into a separate human species over many generations. The different environmental pressures, small founding population, and genetic isolation could drive evolutionary changes that make Mars humans biologically distinct from Earth humans. The communication degradation between Earth and Mars would worsen over time as the cultures diverge. The time delays, cultural differences, and divergent priorities would make meaningful communication increasingly difficult. Mars colonies could become effectively isolated from Earth civilization. The technological divergence between Earth and Mars would accelerate over time. Mars technology would be optimized for Mars conditions and survival requirements, while Earth technology would continue evolving for Earth conditions. The technological compatibility between Earth and Mars would gradually disappear. The scientific research limitations on Mars would prevent colonists from contributing to human knowledge advancement. The survival requirements would consume all available resources and expertise, leaving little capacity for basic research or technological innovation. Mars colonies could become scientific dead ends. The educational limitations for Mars-born children would prevent them from reaching their full potential. The limited resources, small population, and survival focus would make it impossible to provide the diverse, high-quality education that children need for optimal development. The social mobility limitations on Mars would create rigid caste systems based on survival skills and resource access. Unlike Earth societies where people can change careers and social positions, Mars colonists would be locked into survival roles with little opportunity for personal growth or career change. The social stratification on Mars would become increasingly rigid as survival skills determine social status and resource allocation. Those with critical technical expertise would hold disproportionate power over life and death decisions, while those with less essential skills would become dependent on others for survival. This dependency would create authoritarian social structures that could persist for generations. The democratic governance challenges on Mars would be unlike anything faced on Earth. When every decision affects survival and resources are limited, democratic processes might be too slow and inefficient for the rapid decision-making that Mars survival requires. The tendency would be toward authoritarian leadership structures that prioritize efficiency over individual rights. The human rights protections that we take for granted on Earth would be difficult to maintain on Mars when survival is at stake. Privacy rights, freedom of movement, and individual autonomy would all be subordinated to collective survival needs. The social contract on Mars would necessarily be more restrictive than anything acceptable in Earth societies. The conflict resolution mechanisms on Mars would need to account for the fact that banishment or imprisonment aren't viable options when everyone's survival depends on cooperation. How do you deal with someone who commits crimes or refuses to cooperate when you can't remove them from the community? The social control mechanisms would need to be more sophisticated and potentially more oppressive than Earth systems. The mental health crisis that would inevitably develop in Mars colonies would be difficult to address with limited resources and expertise. The combination of isolation, stress, confinement, and survival pressure would create psychological problems that could destabilize the entire community. Mass psychological breakdowns could doom entire colonies. The suicide contagion risk in small, isolated Mars communities would be extremely high. The suicide of one community member could trigger additional suicides among people who are already dealing with extreme psychological stress. The loss of even a few people to suicide could make a small colony unviable. The reproductive pressure on Mars colonists would create ethical dilemmas about forced reproduction and genetic selection. The survival of the colony might require people to have children even if they don't want to, or to prevent certain people from reproducing to maintain genetic diversity. These reproductive controls would violate basic human rights. The child welfare issues on Mars would be unprecedented. Children would grow up in an environment of constant danger with no access to the natural world, limited social interaction, and the knowledge that their survival depends on technology that could fail at any moment. The psychological damage from such an upbringing could be severe and irreversible. The educational resource limitations on Mars would prevent children from receiving the broad, diverse education they need for healthy development. With limited books, no internet access, and few teachers, Mars-born children would have severely restricted learning opportunities compared to Earth children. The career limitation problems for Mars-born individuals would be extreme. Unlike Earth, where people can choose from thousands of different careers, Mars colonies would have only a few dozen essential roles. Most people would be forced into careers based on colony needs rather than personal interests or aptitudes. The innovation stagnation on Mars would result from the small population and survival focus. Innovation requires diverse perspectives, cross-pollination of ideas, and the freedom to experiment and fail. Mars colonies would have none of these conditions, leading to technological and cultural stagnation. The knowledge loss problem would accelerate over generations as survival skills become prioritized over academic knowledge. Complex scientific and technical knowledge that isn't directly relevant to Mars survival would be gradually lost, making the colony increasingly dependent on Earth for intellectual advancement. The cultural impoverishment of Mars colonies would result from the focus on survival over cultural development. Art, music, literature, and other cultural expressions require leisure time and resources that would be unavailable on Mars. The psychological impact of cultural poverty would compound other mental health problems. The religious and spiritual challenges on Mars would be profound. Traditional Earth religions would struggle to adapt to life on another planet, while the harsh survival conditions would make spiritual contemplation difficult. The loss of spiritual and religious support systems would add to the psychological burden of Mars colonists. The generational conflict potential between Earth-born and Mars-born colonists would be enormous. Earth-born colonists would have memories of a rich, diverse world with abundant resources, while Mars-born individuals would know only scarcity and survival. These different perspectives could create irreconcilable conflicts within colonies. The leadership succession problems in Mars colonies would be critical for long-term survival. Unlike Earth societies where leadership can be replaced through elections or other peaceful means, Mars colonies would be dependent on individuals with specific technical expertise. The death or incapacitation of key leaders could doom entire colonies. The resource allocation conflicts would become more severe as Mars colonies grow and resources become more scarce. Decisions about who gets access to limited medical supplies, food, water, and energy would create enormous social tensions. These conflicts could escalate into violence that destroys the social cohesion necessary for survival. The technological dependency trap would make Mars colonies increasingly vulnerable over time. As Earth technology advances and Mars technology stagnates, the gap would widen until Mars colonies become completely dependent on Earth for any technological advancement. This dependency would make true independence impossible. The environmental degradation on Mars would accelerate as colonies grow and industrial activities expand. The mining, manufacturing, and waste disposal needed to support larger populations would permanently damage the Martian environment, potentially making it even less habitable for future generations. The terraforming timeline realities would make atmospheric modification irrelevant for hundreds of generations of Mars colonists. Even the most optimistic terraforming scenarios would take thousands of years to create breathable atmospheres and comfortable temperatures. The first 1,000 generations of Mars colonists would need to survive in the current hostile environment. The planetary protection violations that Mars colonization would inevitably cause could destroy unique Martian ecosystems before we even discover them. The contamination from human activities could eliminate potential Martian life forms and destroy irreplaceable scientific opportunities to study alternative evolutionary pathways. The ethical implications of Mars colonization extend beyond the colonists themselves to the impact on Earth society. The enormous resources required for Mars colonization could be used to solve pressing problems on Earth like poverty, disease, and environmental degradation. The opportunity cost of Mars colonization might be measured in millions of Earth lives that could be saved with the same resources. The false hope problem with Mars colonization could actually make Earth's environmental problems worse by encouraging people to believe that we have a backup planet if Earth becomes uninhabitable. This false sense of security could reduce the urgency of addressing climate change and environmental destruction on Earth. The brain drain effect of Mars colonization would remove some of Earth's most talented and educated people from contributing to Earth society. The scientists, engineers, and other experts needed for Mars missions could instead be working on solutions to Earth's problems. The international cooperation requirements for Mars colonization could actually increase tensions between Earth nations as they compete for Mars resources and territory. The potential for conflict over Mars could destabilize international relations and increase the risk of war on Earth. The military implications of Mars colonization could lead to the weaponization of space and the extension of Earth conflicts to other planets. Mars colonies could become military targets or staging areas for space-based weapons, making both Earth and Mars less safe. The economic inequality implications of Mars colonization would be enormous. Only the wealthiest individuals and nations would have access to Mars colonization opportunities, potentially creating a new form of inequality where the rich escape to other planets while the poor are left to deal with Earth's problems. The selection bias in Mars colonization would favor young, healthy, educated people from wealthy nations, raising questions about who deserves the opportunity to survive if Earth faces catastrophe. The selection criteria would inevitably discriminate against older people, disabled individuals, and those from developing nations. The psychological screening requirements for Mars colonists would need to identify people capable of permanent exile and extreme isolation, but these same psychological traits might be incompatible with healthy social relationships and mental health. The people best suited for Mars survival might be least suited for creating healthy communities. The training opportunity costs for Mars colonists would be enormous. The decades of education and training required for Mars survival would prevent colonists from contributing to Earth society during their most productive years. The human capital investment in Mars colonization might have better returns if invested in Earth-based solutions. The training opportunity costs become even more staggering when you consider that each Mars colonist would require the equivalent of multiple advanced degrees in engineering, medicine, agriculture, and other critical fields. The educational resources needed to train a single Mars-capable individual could instead train dozens of specialists who could contribute to solving Earth's problems. We're essentially talking about creating Renaissance polymaths in an age of specialization. The psychological preparation for Mars colonization would require conditioning people to accept permanent separation from everything they've ever known and loved. The mental health implications of this psychological conditioning are unknown, but deliberately training people to sever emotional attachments could create individuals who are psychologically damaged in ways that make them unsuitable for creating healthy communities. The family planning restrictions that would be necessary on Mars would violate fundamental human rights about reproductive freedom. Colony survival might require limiting family sizes, controlling who can reproduce, and making decisions about genetic selection that would be considered eugenics on Earth. The social control mechanisms needed for Mars survival would be incompatible with human dignity and freedom. The medical experimentation aspect of Mars colonization would essentially turn colonists into test subjects for long-term space medicine research. We have no idea what the long-term health effects of Mars colonization would be, making early colonists unwitting participants in medical experiments that could have devastating consequences for their health and the health of their children. The informed consent problems for Mars colonization are enormous because we simply don't know enough about the long-term consequences to properly inform potential colonists about the risks they're accepting. How can someone give informed consent to permanent exile on a planet where the long-term survival prospects are unknown? The liability and insurance impossibilities for Mars missions mean that colonists would have no legal recourse if missions fail or if they suffer health problems from Mars. Exposure. The risks are so enormous and unpredictable that no insurance system could cover them, leaving colonists completely vulnerable to catastrophic losses. The return journey medical requirements would make it impossible for most long-term Mars residents to ever return to Earth. The bone density loss, muscle atrophy, cardiovascular deconditioning, and radiation exposure would make many Mars colonists physically unable to survive Earth's gravity and atmosphere. Mars colonization would be permanent exile for most participants. The adaptation timeline for Mars-born humans would make them increasingly incompatible with Earth environments over multiple generations. Children born on Mars would have bone structures, muscle development, and cardiovascular systems adapted to Mars conditions. They might be physically unable to visit Earth even if transportation were available. The evolutionary pressure on Mars humans would drive genetic changes that could make them a separate species over many generations. The small founding population, environmental pressures, and genetic isolation would accelerate evolutionary changes that could make Mars humans biologically incompatible with Earth humans for reproduction. The communication breakdown between Earth and Mars cultures would accelerate as the societies diverge. The time delays, cultural differences, and survival priorities would make meaningful communication increasingly difficult. Mars colonies could become as alien to Earth culture as any extraterrestrial civilization. The technological incompatibility between Earth and Mars would grow over time as each environment drives different technological solutions. Mars technology would be optimized for survival in hostile conditions, while Earth technology would continue evolving for comfort and efficiency. The technological gap would make cooperation increasingly difficult. The scientific isolation of Mars colonies would prevent them from contributing to human knowledge advancement. The survival requirements would consume all available intellectual resources, leaving no capacity for basic research or scientific discovery. Mars colonies could become intellectual dead ends that contribute nothing to human understanding. The cultural stagnation on Mars would result from the complete focus on survival over cultural development. The art, music, literature, and philosophical traditions that define human civilization would be impossible to maintain when every resource must be devoted to staying alive. Mars colonists would lose much of what makes us human. The educational poverty for Mars-born children would prevent them from reaching their intellectual potential. With limited teachers, books, and learning resources, Mars children would receive an education that's impoverished compared to Earth standards. This educational limitation would compound over generations, creating an increasingly less capable population. The social mobility elimination on Mars would create rigid caste systems where people are locked into survival roles with no opportunity for personal growth or career change. Unlike Earth societies where people can pursue their interests and talents, Mars colonists would be assigned roles based on colony needs regardless of their personal preferences or abilities. The democratic impossibility on Mars would result from the need for rapid, expert decision-making in survival situations. Democratic processes that work on Earth would be too slow and inefficient for Mars survival. The tendency would be toward authoritarian leadership structures that prioritize efficiency over individual rights and freedoms. The human rights erosion on Mars would be inevitable when survival takes precedence over individual freedoms. Privacy rights, freedom of movement, reproductive autonomy, and other basic human rights would all be subordinated to collective survival needs. The social contract on Mars would be more restrictive than anything acceptable in free societies. The mental health epidemic that would develop in Mars colonies would be impossible to address with limited resources and expertise. The combination of isolation, stress, confinement, and survival pressure would create psychological problems that could destabilize entire communities. The suicide risk alone could make small colonies unviable. The child welfare crisis on Mars would be unprecedented in human history. Children would grow up in environments of constant danger with no access to nature, limited social interaction, and the knowledge that their survival depends on technology that could fail. The psychological damage from such upbringings could be severe and irreversible. The reproductive coercion that might be necessary for colony survival would violate basic human rights about reproductive freedom. Small populations might require people to have children even if they don't want to, or prevent certain people from reproducing to maintain genetic diversity. These controls would be incompatible with human dignity. The genetic bottleneck problems would doom Mars colonies to gradual genetic decline over multiple generations. Even a founding population of several hundred people would have insufficient genetic diversity to maintain a healthy population long-term. Inbreeding depression would gradually weaken the population and increase rates of genetic disorders. The knowledge preservation impossibility would result in the gradual loss of human, intellectual achievements over generations. The survival focus would prioritize practical skills over academic knowledge, leading to the loss of scientific, cultural, and philosophical knowledge that took millennia to develop on Earth. The innovation stagnation on Mars would result from the small population and survival focus. Innovation requires diverse perspectives, cross-pollination of ideas, and the freedom to experiment and fail. Mars colonies would have none of these conditions, leading to technological and intellectual stagnation. The resource depletion timeline for Mars colonies would be much shorter than most people realize. The easily accessible resources would be consumed quickly, forcing colonists to undertake increasingly difficult and dangerous extraction operations. The resource base that supports early colonies might not be sufficient for long-term sustainability. The environmental destruction from Mars colonization would accelerate as populations grow and industrial activities expand. The mining, manufacturing, and waste disposal needed to support larger populations would permanently damage the Martian environment, potentially making it even less habitable for future generations. The terraforming impossibility means that atmospheric modification wouldn't help the first 1,000 generations of Mars colonists. Even the most optimistic terraforming scenarios would take thousands of years to create breathable atmospheres. The technology and energy requirements for terraforming are so enormous that they might never be achievable. The planetary protection violations from Mars colonization could destroy unique Martian ecosystems before we discover them. Human contamination could eliminate potential Martian life forms and destroy irreplaceable scientific opportunities to study alternative evolutionary pathways. We might be destroying the very thing we're trying to find. The false backup planet narrative surrounding Mars colonization ignores the reality that Mars colonies would be completely dependent on Earth for centuries. If Earth civilization collapses, Mars colonies would follow within months as their life support systems fail and replacement parts run out. Mars isn't a backup for Earth, it's an extension of Earth that's even more vulnerable to catastrophic failure. If you are still watching, make sure to subscribe to the channel and give a thumbs up. And check out this other video at the left side of the screen. This is why we will never leave the Milky Way. This is why we can't leave the solar system. In this video, discover the real science behind our cosmic confinement and the fundamental barriers that make interstellar travel nearly impossible. See you there.